professor. His name is Kim Miller. He was a physics professor. He's a very, very good physics professor. I also always call him as a magician. Any class he teach, he make it fun. And listen to his classes are very enjoyable. So what he does is using the information on chapter 8, momentum and collision, to become a professional witness in auto accident. See? That based on something is only one chapter worth of information. And then they go to the computer, set it up as a program on the two-dimensional momentum changes. And from the situation in the auto accident, final form, it can working backward. What is the initial velocity of the auto accident automobile? And from there on, they start defending his customer. He worked for a lawyer, and the lawyer using the, hey, please using the physics chapter 8 information to calculating those initial velocity, initial situation to defend our customer. So he become very, very popular professional witness. He fly all over United States doing this. So and then he retired and to just concentrate doing that. Educational scholarship. So that's where the money comes from. Okay. So we like to mention this to you. So even a very simple chapters, if you apply it properly, then that's become your career and profession. In the Physics 31B classes, we're teaching only 3 chapters of physics classes in optics. That is my professional specialty. Professional specialty Wayman Liu has is optics. It's called optical engineering, called lasers. So based on that 3 chapters, information, and then expanding a little further, study a little bit here and there, and more updated information, then they give me a title as senior optical engineer or senior scientist at JPL as well as TRW and Xerox. So from this point of view, we want to emphasize, you don't have to master of everything to be good. You should master few chapters in physics, then that become your career and making some comfortable living. I don't mind to tell you that ever since I graduated from Cal State Northridge, I have not missed one day of work. Sometimes one day I had to work 3 different jobs. For 10 years, Wayman Liu, between 1984 to 1994, I had to have a 3 full-time job. That is really killing my marriage. That means if I want to work, I can work that much. Okay. So of course now I become smarter now. So I will hire some other people to do the work rather than myself. Okay. My former student is all become senior engineer now. Some of them become senior scientists at JPL. So they want to come back to help me. So if you want to help me, go ahead. So you do the work. I just doing the consulting, doing the advice. So we like to learn something in here is on the starting section 8.1. Actually, all the chapters is a very simple development based on few principles. If you look at chapter 7 on the formula sheet, it's not that many. question. There are many formula. The most important in chapter 7 is conservation of energy. U sub I plus K sub I equal to U sub F plus K sub F. That's all that is. And then you keep using that solving problems. So that teach you that. Now, in the chapter 8, again, is a few important information. In these cases, we like to say is conservation of momentum. So we like to find this out. So 8.1 is called momentum and conservation. Momentum and conservation. In these cases, we like to emphasize linear, means one dimension. Linear is, in which case, go one dimension. Or we always start one dimension and go forward. So in reality, we can start three dimensions. Okay. So first, we like to say what is momentum. Momentum is not created by Isaac Newton. Isaac Newton is an organizer. We will put all the different things regarding about motion and separate development, and then put up in to a book form. And that's what his expression, his contribution. This gentleman keep thinking about there's a motion. You have talking about motion, and this Jean, J-E-A-N, is a French. Jean say that's supposedly have a quality of motion. Quality of motion. So Jean said we want to define quality of motion. This quality of motion we like to call as momentum, P. This P is related to mass and velocity. Okay, the mass and velocity. So quality of motion means the product of m times v is called momentum. This is momentum. Momentum. So now we like to go back to Newton's second law. Like to go back to Newton's second law. Newton's second law talking about is forces. We say the acceleration is equal to the force proportional, directly proportional to force, and indirectly proportional to the mass. Or it says the change of motion is evidence of force. Change of motion, change of motion is evidence of force. So all force is equal to ma. So now we like to say, how about linearly? We only consider one dimension. One dimension. If we consider one dimension, A along the x direction is equal to ax. So we have fx is equal to max. Okay, we consider one dimension first. If you consider one dimension, then we have the following thing to consider. In which cases we like to have fx equal to max. And then ax equal to vx. dvx dt. So, or we like to say f sub x is equal to m dvx dt, or f sub x equal to d mv sub x dt vx. So f sub x equal to d dt p sub x. Ladies and gentlemen, so what is a force? According to this, only consider one dimension. Force we can define in another way very nicely. Force is time rate change of momentum. Isn't that nice? So now you're doing the things completely. What's the V? V time rate change of location. What's association? Association is time rate change of velocity. What is force? Force is a time rate change of momentum. So all this into a thing as completed. So now we consider something important. So if we consider in the 3 dimension, then you have force along the x direction, force along the y direction. So for the 3 dimension, 3D, that we have force is equal to time rate change of, so something like that. So we finally get to this time rate change of momentum. So now we like to talk about this now. In the collision setting, when you're talking about collision, there's 2 objects involved. In which cases involving on P1 and P2. Okay, so we have 2 objects, M1, M2. So here is M1. It moves a velocity V1. So it colliding another one, in which case this is V2. This is called M2. So we like to say this is a V1 sub I, this is a V2 sub I. And after they collide, and they go separately, so that this one go like this direction, in which case a V1F, and then this one go on to, in which case a V2F, like this. Okay, so it collide and go. So now we impose. This is the isolated system. This is the isolated system. There's no outside force acting on it except by itself, initial velocity and final velocity. So we say force is the change of momentum. Change of momentum, d dt. Change of momentum, but this is a